We'll now assume the same setup as in graph 22.3, except that we'll no longer assume that insurance companies can tell the difference between high-risk and low-risk types. In other words, we'll now introduce asymmetric information. As in graph 22.3, high-risk data types will choose the actuarially fair full insurance policy A if offered a full menu of actuarially fair insurance policies targeted at high-risk types. A full menu of actuarially fair insurance contracts targeted at low-risk types would lie on a shallower line because delta is less than theta. Individuals in our graph become better off as benefit levels increase and premium levels fall. In other words, they become better off as we move to the southeast in the graph. A high-risk theta type who's purchasing full actuarially fair insurance policy A would therefore prefer to buy any policy that lies in the shaded magenta region, including a number of policies that lie on the shallower green contract curve that's aimed at low-risk types. Thus, if insurance companies offer the actuarially fair policies aimed at low-risk types, and they can't tell who is a high-risk type and who is a low-risk type, they'll have high-risk types purchasing on the low-risk actuarially fair insurance line. The only policies on the actuarially fair insurance line aimed at low-risk types that high-risk types would not prefer to the policy A are those that lie to the left of point B. When insurance companies can't tell the difference between high and low-risk types, they can therefore offer the full menu of actuarially fair insurance contracts only to the high-risk types, and then offer only the highlighted green portion of the actuarially fair insurance policy line aimed at low-risk types. The low-risk delta type will then optimize at the insurance policy B. This, then, is a picture of a separating equilibrium, where separate policies are offered to high and low-risk types, and high-risk types have no incentive to pretend to be low-risk types and buy from the menu of insurance contracts aimed at low-risk types. We can tell immediately that this equilibrium is inefficient relative to the full information equilibrium, where insurance companies can tell high-risk types from low-risk types and can therefore offer a full menu of actuarially fair insurance contracts to both types. High-risk types buy the same policy in both cases, so they are no better or worse off when there's asymmetric information. But low-risk types can no longer fully insure, and are thus worse off than they were under full information. In panel B, we illustrate a similar graph, except that now we draw the indifference curve for low-risk types that optimizes along the high-risk actuarially fair insurance policy line. In other words, if only the actuarially fair insurance policies aimed at high-risk types were offered in the market, individuals of low-risk type would optimize at policy C. Within chapter exercises 22b.8 through 22b.10, then ask questions in relation to this panel B. You should be able to answer those questions if you understand what we did in panel A. We have now once again illustrated the adverse selection problem in insurance markets. When insurance companies cannot tell high-risk types from low-risk types, they are unable to offer a full menu of actuarially fair insurance policies to all risk types. They can only offer them to the high-risk types. The reason they can't offer a full menu of actuarially fair insurance contracts to low-risk types is because high-risk types would then choose from those contracts. Thus, low-risk types are offered only a restricted portion of the set of actuarially fair insurance policies and can no longer fully insure as they could in the full information equilibrium.